Hello everyone, today we're going to discuss the basics of circular motion. This is a three-part series, so make sure you watch part 2 and 3 after. So first we're going to discuss period and frequency. So the period is simply how long it takes to make one revolution around a circle. So let's say you have a circle here, and you time how long it takes to make this one revolution. That would be your period. So it'll also equal so it'll be the time over how many revolutions you make, which also equals 1 over the frequency. So the frequency is the amount of time it takes to go around the circle in a given amount of time. So that means if you go around the circle one time, how long did that take, basically? So it'll be the amount of revolutions in a given time, which also equals 1 over the period. Alright, so let's do an example of these. So a ball on a string is swung in a circle 10 times in 2 seconds. What is the ball's period and frequency? So we have 10 revolutions in 2 seconds. So we can start by solving the period or the frequency first, but I'll just do the frequency. So the frequency is the amount of times it goes around, which is 10, in the amount of time, which is 2 seconds. So this will be a frequency of 5 1/over seconds, which you may see this 1/over seconds as hertz. And then to find the period, you simply can just do 1 over frequency, which equals 1 over 5, and that'll be 1 over 5 seconds. And if you were to solve it with time over revolutions, you would also get 1 over 5. Okay, now let's discuss tangential speed. So the tangential speed is basically how fast you're moving tangent to the circle that you're moving on. So if we have a circle, and I'll try my best to draw a circle, your speed at any point here is going to be your tangential speed, in opposed to the speed that you're moving in the circle, but that'll be talked about in a later unit. So your tangential speed is the amount tangent. So it's equal to 2 pi r, which is the radius, over the period of your travel. So to derive this equation, we know that speed is the distance over time. So when it relates to a circle, the distance is one lap around the circle, which is the circumference, and the circumference equals 2 pi r, and the time to go around one circle is just t. And so that's how we get this equation up here. And then we can also solve it with frequency, and since we know frequency is just 1 over, or the period is just 1 over frequency, we can plug that in and get 2 pi rf, and that's how we get the second equation here. Alright, so let's do an example with tangential speed. So Bob runs around a track at a linear speed, or tangential speed, of 7 meters per second. He makes 5 revolutions in 100 seconds. What is the radius of the track he's running on? Alright, so let's write out what we're given. So we know we have a velocity of 7 meters per second and a frequency, which we're not directly given the frequency or the period, but we know he makes 5 revolutions in 100 seconds. So we can plug in our 5 revolutions here in our 100 seconds to get a frequency of 0.05 1 over seconds. And so we want to know what the radius is. So we can simply use the equations that we just learned about to get the tangential speed equal to 2 pi r times the frequency. And if we divide everything over to get r by itself, we get the tangential speed over 2 pi f. And if we plug in the values that we know, we can solve for the radius, which in this case is 22.3 meters. Okay, now this last topic is a little bit more confusing, but it's the centripetal acceleration. Now you may be thinking, if we have a circle with a constant velocity, let's say something's traveling around this circle with a constant velocity or a constant tangential speed. Now the magnitude of the speed might be the same, but the direction is changing. So we know from the first unit of physics that if the velocity is changing, there must be some acceleration, but where would the acceleration be? So let's try to figure that out, right? So we know the centripetal acceleration is going to be the change in velocity over time. So we'll still have velocity final minus velocity initial over time. So let's take, so if we say like a 1 second increment, we know that the centripetal acceleration direction, since the time's a scalar, is just going to be the final velocity minus the initial velocity. So let's try to use this picture here to figure this out. So we have a velocity going in this direction, and we'll say this is velocity initial, and then after 1 second it's changed to this, as we'll say this is velocity final. So if we draw these vectors out, we have the velocity final, which looks like this, and the velocity initial, which is just straight like this. So if we were to subtract these two vectors, we could draw the final vector first, like this, and then the initial vector comes from the head of the first vector, but in the opposite direction, like this. And we notice that this resultant vector is basically just straight down, and this is our centripetal acceleration. So at this point, the centripetal acceleration is straight down. And so if we were going to do this at every point, we would see that the centripetal acceleration is always pointed towards the center of the circle. So this centripetal acceleration causes this velocity to change direction as it goes around, and is always pointing towards the center. And something important about this centripetal acceleration is it's also changing. Even though the magnitude might be constant, the direction is changing, so we cannot use kinematic equations from the first unit of physics. We have to use a different way to determine the centripetal acceleration, which, if I scroll down here, we have 3 equations that we can use for centripetal acceleration that are basically saying the same thing. This is the main one right here. The centripetal acceleration equals the velocity or tangential speed squared over the radius of the circle. And we can simply derive these two formulas from this one up here. So if we have the acceleration is velocity squared over r, we know what this tangential speed is. We know that it's the 2 pi r from the circumference over the period squared over the radius. So if we go ahead and solve this out, we would get 4 pi squared r squared over t squared r. And so these two r's will cancel, and we'll get 4 pi squared r over t squared. And that is where that comes from. And we could plug in 1 over f for t squared here to get that equation. Alright, so let's do an example with this centripetal acceleration. Alright, so we have Bob rides a Ferris wheel with a radius of 5 meters. He has an acceleration towards the center of the Ferris wheel at 0.2 meters per second squared. If he made 10 revolutions, how long was he on the Ferris wheel for? Okay, so as always, let's write down what are we given here. So we know the radius is equal to 5 meters. There's some centripetal acceleration of 0.2 meters per second squared. And we know that he made 10 revolutions. And we want to know this total time, which I'll know as t total. So that doesn't necessarily mean we need to know the period, but if we know the period, we can use the revolutions to find this total time. So let's use that centripetal acceleration with the period in it. If we know the radius and the centripetal acceleration, we can solve for period, and this should be squared. So if we rearrange this equation and take the square root, we can plug in the values that were given. The radius is 5 and the centripetal acceleration is 0.2. Okay, and if we go ahead and solve that out, we get a period equal to 31.42 seconds. And so now we need to know what the total time is. Well, we know how long it took him to make 1 revolution, and we're given 10 revolutions. And so we know that the period is equal to the time total over the revolutions. So if we simply multiply the period by the revolutions, we can solve for this total time. So 31.42 times the amount of revolutions, which is 10, we get a total time of 314.2 seconds. So that's how long Bob was riding the Ferris wheel. Alright, so that's all I got for this first part. Leave your questions down below and stay tuned for part 2 where we'll talk about centripetal force.